You are welcome to Jetstream Tutorials. I'm Lukman Abdulkarim Zakari by name, your chemistry tutor. So today I will be taking us on Iupac nomenclature of some organic compounds. Most organic chemistry students, or I can say most chemistry students in general, find this very challenging, naming some organic compounds. Like, wow, some of the students, they tell you, sir, where are we going to start from? Wow, very easier. So in this tutorial video, I'm going to show you how you can easily name these compounds. In fact, if you don't know how to name organic compounds as far as chemistry is concerned, that is a big trouble. Now, follow me as I move on. Now, the first question says, give the Iupac nomenclature of the following organic compounds, which you have A here. Now, if you observe, this particular compound is saturated alkane. How do we know that it is a saturated alkane? It is a saturated alkane because you take a look at the number of carbon atoms. We have 2, and each carbon atom is surrounded by 4 bonds. That makes it to become a saturated alkane. Now, saturated and in addition substituted. So you have to be very careful here. Now we have 2 bromine atoms attached to this carbon, and then we have this particular carbon not attached to any hetero atom. So in this case, your numbering will start from where you have more substituent groups. So we have here, so our numbering is going to start from here. So we have 1 here, we have 2 here. So this will be carbon 1 and this will be carbon 2. So the parent name here is F. That means we have 2. F. In that case, ethane. Okay? So we have 1,1-dibromoethane. Is that okay? So this is now going to imply that we have 1, 1 di, okay, bromoethane. Is that understood? Yes. So, bromoethane. So this is the name of this very particular organic compound, as we can see here, being saturated alkane. Then for the number 2, which is the second part of the question, which is B part, we have 1 carbon atom here. We have another carbon atom here. So which means we have 2. Is that okay? What you are seeing here are what? Covalent bonds. So from here we have our numbering starting from this side. Any side you can start your numbering from. So I prefer starting from the right. So this will be 1, this will be 2. So in this case we have 1 bromine at carbon 1 and another bromine at carbon 2. So that becomes 1 bromo, okay, 2, okay, 1, 2 dibromo, yes, we have 1, 2 dibromo, what? Ethane. Now, why is it 1, 2? It is 1, 2 di, that is, we have 2 bromine atoms at different carbon. At carbon 1 we have 1 bromine, at carbon 2 we have another bromine. We can say 1 bromo, 2 bromo. Instead of repeating, we just make use of 1, 2. We use comma to separate between the 2 numbers where the substituent groups are attached to. So in this case we have 1, 2. At carbon 1 and 2, we have 2 bromine atoms, ethane, on 2 carbon chains. Since we have 2 atoms on the carbon chain, that becomes F, that is ethane. Is that understood? Then for this one, we have, okay, a bromine here and another chlorine here. So on this very particular carbon, so the number of carbon atoms here are 3. 1, 2, 3. So my numbering will start in preference to where I have more substituent groups. So this will be 1, this will be 2, this will be 3. So in this case, alphabetical order must be obeyed here in terms of writing the substituent atoms attached to the carbon chain. So here we have bromine and chlorine. So bromine should come first when I'm writing the names of the substituents in the name of this organic compound. So the parent name is propane because we have 3 carbon atoms. That makes it to be prop. That is propane. So in this case, I have 1 bromo. Okay, 1 bromo. So okay, then we have 1 chloro. 1 chloro. Is that okay? Propane. So that is the name of this very particular compound. Then that takes us to the second one, the fourth one. So we have carbon atoms here to be 3. So we have 1, we have 2, we have 3 in this case. So this is going to be 1 bromo, 2 chloro. Is that okay? So 1 bromo, 2 chloropropane. So that is the name of this organic compound, Iupac. Then coming to number 5. This very particular one indicates that we have 1, 2, 3, 4 carbon atoms. Is that okay? So which one are we going to give preference to? We are going to give preference to chlorine. So our numbering will start from here. So I have 1, 2, 3, 4. Now this is because chlorine is more reactive than bromine. So in this case, we give more preference here. You can't start your numbering from this side. Is that understood? So here we have 1 chloro, okay, 4 bromo, butane. Is that okay? Then for this very particular one, numbering will start from here. So our carbon atom is here, not here. So 1, 2, 3, 4, we got 5, we have 6. So the parent name here is hexane. We are dealing with saturated alkane substituted. So we have hexane. This is going to be 1 chlorohexane. Is that understood? Then coming to this one, you can see what we are dealing with here is unsaturated hydrocarbon and alkene, preferably. This is because of this double unsaturated bond present in the carbon chain. So when numbering this type of compound, in order to provide the Iupac nomenclature, what you do is your numbering will start from the side that is closer to the double bond, so as to give preference to the double bond. The double bond in the carbon chain must have the least possible number when numbering. So if you start numbering from here, it is still far, so you have to start numbering from this side. Are we together? So now we have 1, 2, 3, 4, 5. Now in this case, the double bond is between carbon 2 and 3. So the parent name here is pentene, or we can say pent2ene. That is the parent name. So in this case, we write it, since there is no any substituted group or pendant group attached to the carbon chain, we will just go ahead and say this is pent2ene. That is the name of the compound. Pent, 5 carbon atoms, 2ene at carbon 2, which is having the lowest possible number, is ene. We have a double bond there. Ene in organic here refers to what? Double bond. Is that okay? Then we come to this, the same thing applies here. So we start our numbering from here. This is 1, 2, we got 3, we got 4, we got 5, we got 6, we got 7, we got 8. So in this case, we are still dealing with unsaturated hydrocarbon. In this case, alkene, precisely. So we have hex, okay, hex 1 in this case, since the double bond is between carbon what? 1 and carbon 2. Is that understood? Then coming to this very one, we are back to unsaturated substituted alkene in this case. Now, you observe that there is branching in terms of the way the carbon chain is, but it is not really a complete branch. It's just the nature of the arrangement of the covalent bonds and the carbon atoms in the molecule. Now, what we do is we identify the longest possible chain. Now, the chain goes this way. Okay, we have 1 carbon here, 2, 3, 4. So we have 4 carbon atoms present in this molecule. Okay, attached to the other carbon here, we have chlorine. So in this case, there is another what? There is another unsaturation present here. So which means our counting or numbering will be in preference to which side? Can it be this side or this side? If we start from here, 1, 2, 3, 4. 1, 2, 3, 4. Anywhere the numbering goes is okay. But if you start from here, 1, 2, the chlorine atom will not have the lowest possible number. If we start from here, 1, 2, 3, 4. So the lowest possible number is going to be in the sense that the double bond must have the lowest possible number, and likewise this. So if I start from here, 1, 2, this will not have the lowest possible number, which will violate the rule. So my numbering will start from here, 1, 2, 3, 4. Since if I start from here, 1, 2, 3, the position of the double bond will not be affected, whether I start from this side or start from this side. But I have to take into proper consideration this chlorine atom. It must also have the lowest possible number present in the compound here. So by the time I am going to number the chain, I should do it in such a way that the chlorine atom must have the lowest possible number. So these are the problems many students face when it comes to giving names to organic compounds like this. So you have to take your time. So from this implies that the name of this compound is, we have 2 chloro what? But 2-in. Can we say that? 2 chloro but 2-in. That is that. So we have 2 chloro but 2-in. So that is what we have here. Start by writing the position of the pendant group in the chain in order to get this. Then coming to this very particular one, we are going to start our numbering from this side. So we have 1, we have 2, we got 3, we got 4. So in this case, we have a substituent group, which is this, and also what? This. So in this case, we have 2,3 dimethyl but 2-in. Is that understood? 2,3. This is the name. Implies that we have 2,3 dimethyl. Is that okay? But 2-in. That is the name of this organic compound. So you can see that in the organic compound chain, we have 4 carbon atoms. When you count from here, we have 1, 2, 3, 4. And then we have a substituent at carbon 3. We have another substituent at carbon 2. Now the substituent at carbon 2 and 3 are the same. They are methyl groups. And how many are they? 2. That is why we use di here. Is that understood? Then, coming to this very particular one, we have a benzene ring, attached to it a methyl group. So this can be methylbenzene. Methylbenzene. In other words, you can refer to this as toluene. Though toluene is a trade name, it is not an Iupac name for this very particular compound. So the Iupac name of this particular compound is methylbenzene. Is that taken? Good. Then coming to this one, we have an alcohol in this to name. So the OH indicates that it is an alcohol. So how do we do that? To name this particular alcohol, look at the chlorine atom attached to this particular chain, which we have how many carbon atoms present there? 1, 2, 3. So the parent name here is what? Propanol. Propanol. So this is going to be 1-chloropropanol. Can that be 1-chloropropanol? Are we starting the numbering from here or the numbering from this side? We give preference to where? We give preference to chlorine here. So this becomes 1-chloropropanol. 1-chloropropanol. Is that understood? Yes. Then this very one is also an alcohol. So our numbering is going to start from this side. Provided you do not have an atom that is more electronegative than the OH group, then numbering should start from where the OH group is, so that the OH group can have the lowest possible number. But since we don't have, methyl group here is less electronegative than, so preference will be given to this side. So our numbering will start from here. So this is 1, 2, 3, 4. Remember I said this numbering starts from here. 1, 2, 3. If you want to name this, you can also say 1-chloropropane-3-ol. Is that okay? So this can be 1-chloro. Is that okay? Propane-3-ol. Is that understood? If you don't want to use 1-chloropropanol, you can use 1-chloropropane-3-ol. Here, you can use alphabetically. We have methyl group, we have hydroxyl group. So alphabetically, which one comes first? Methyl or hydroxyl? Methyl starts from start with letter M, while hydroxyl group start with letter what? Start with letter H. So which one comes first? Methyl. Is that okay? So we say 3-methyl. 3-methyl. Is that okay? Butane. 2-ol. Is that okay? 3-methyl, butane, 2-ol. Then coming to this is hydroxyl group. How do we know that? Due to the presence of the carboxylic group attached to. So how many carbon atoms do we have here? We have 3 carbon atoms. So numbering will start from here. 1, we have 2, we have 3. So in this case, this is going to be 2-methyl what? Propanoic acid. Is that okay? So this is 2-methyl propanoic acid. Because the parent chain here is propanoic acid. Then on the propanoic acid chain, we have what? Methyl at carbon 2. So that is why we have 2-methyl propanoic acid. Is that understood? So I hope you have learned some things that are useful, which you are going to make use of in due course. So don't forget to subscribe to Jetstream Tutorials on YouTube, and try as much as possible to reach out to your friends there, informing them to tell others to also subscribe for more important video tutorials. So thank you very much and remain blessed until we see you another time. Bye bye.